Hi everybody. I've been getting a lot of questions about numbers 7 and 8 from last week's written homework assignment using Gaussian elimination to solve a system of equations. So I thought that I would make a video explaining the solutions to these two problems. I know that Gaussian elimination is definitely a challenging concept, but hopefully this provides a little bit of clarity as to how to do these kinds of problems. So number 7 says to solve the given system using the Gaussian elimination process. The first thing we need to do is we need to rewrite this system in a matrix. So when I write this as a matrix, I copy all of my coefficients over, so I get 5, -4, 2, and -2. And then I have this little line here, and then I get 34 and 14. So this is my system inside a matrix. And just to remind ourselves, we eventually want something that looks like this: 1, 0, 0, 1, and then numbers here and here. Because this basically tells me that x equals this number and y equals this number. So we want it in this form, and we always work with the top row first because that makes it easier to work with the second row later on. So I want a 1 where this 5 is and a 0 where this 4 is. So in order to get a 1 where the 5 is, I certainly could divide this whole row by 5. And then I would have to manipulate it again in order to get that -4 into a 0. I definitely could divide the whole first row by 5 in order to get that 5 into a 1. But that's not the only thing I can do here. So in order to get this 5 into a 1, what if I replaced row 1 with row 1 minus 2 of row 2. So I'm going to replace row 1 with row 1 minus 2 times row 2. So let's write all of this out. First of all, I knew that I wanted a 1 here where this 5 was. So I can get a 1 by saying 5 minus 4. And 4 is exactly twice the element that's right here. So that's how I knew that I wanted to replace this first row with the first row minus 2 times the second row, because that's 5 minus 4, or 5 minus 2 times 2. So here's how we do this. I replace this 5 with a 5 minus 2 times 2. And then I have -4 minus 2 times -2. And 34 minus 2 times 14. So I'm replacing all of those elements with those elements minus twice the row 2. And then the other row stays the same. So let's see here. I get 5 minus 2 times 2. That gives me a 1, which is what I wanted there. And in this second space, I get -4 minus 2 times -2, which is -4 plus 4, or 0, which is what I wanted in this element anyways. And then I get 34 minus 2 times 14. That is 34 minus 28, which is 6. So now my first row is taken care of. I have a 1 and a 0, exactly where I want them. And then I have a 2 and -2 and 14. So now what I want is I want a 0 where this 2 is and a 1 where this -2 is. And again, I can do this a number of different ways. I think I'm going to first divide this whole row by 2. So we're going to divide row 2 by 2 in order to get, you know what, actually let's divide by -2 so that I get a 1 where I want it. So I'm going to divide by -2. If you divided by 2, that's okay. Your algebra will just look a little bit different. So we have 1, 0, 6. And then if I divide row 2 by -2, I get -1, 1, and -7. Now I'm almost there. I just have this -1 that I need to worry about. So now I'm going to replace row 2. If I see that if I add this one, then that takes care of this -1 and it doesn't affect our 1 right here. So I'm going to replace row 2. Let's write this down. Replace row 2 with row 2 plus row 1. So this gives me 1, 0, 6, and then I have -1 plus 1, 1 plus 0, and -7 plus 6. This gives me 1, 0, 6, 0, 1, -1. And finally, I have it in the right form. This tells me that x equals 6 and y equals -1. So this is just one way to do it. If you did it another way and got the same answer, that is totally okay, as long as your math is correct and everything. Yeah, it's important to remember that with Gaussian elimination, we can do it more than one way, just as we can solve systems of equation more than one way. But I personally don't like dealing with fractions, and I'm sure that you don't like dealing with fractions in matrices either. So that's why instead of dividing the first row by 5, since that would have given me a lot of fractions, instead I replaced it with row 1 minus 2 row 2. That way I didn't have to deal with any fractions, and it got it into the right form a lot quicker. So maybe it's a chance for us to be a little bit creative and to see all of the different ways that we can make our matrix to look like what we want it to look like. All right, that was number 7. Let's look next at number 8. So again, we want to use Gaussian elimination here, and I'm going to transfer this into a matrix. I get 2, -8, and 3, -6, 24, and -6. So again, I want to get a 1 where this 2 is right now. But if I were to divide this whole row by 2, then I would end up with a 3/2, and I don't really want that. So maybe instead I will replace this row with, let's write this down. I'm going to replace row 1 with row 1 plus 1/3 the second row. Because if I add a third of the second row, I will be adding a -2, right? If I add 1/3 times -6, that's -2. And if I add it, oh wait, I don't want to do that, do I? Well, sorry, we don't want a 0 there yet, do we? So maybe I will just divide this row by 2. We'll end up with a 3/2, but that's not so bad. So let's see, if I divide by 2, divide row 1 by 2, then I get 1, -4, 3/2, -6, 24, and -6. Okay, so now what I want to do is I want this -4 to turn into a 0. And in order to do that, I am going to add 1/6 of row 2 to row 1. I want to add a 4 to this basically. So a 4 is 1/6 of this 24. So I'm going to replace row 1 with row 1 plus 1/6 row 2. Okay, so this gives me 1 plus 1/6 of -6, -4 plus 1/6 24, and 3/2 plus 1/6 -6, -6 24, negative 6. All right, let's see what happens here. If I have 1/6 times negative 6, that's negative 1, plus 1 is 0. And then I get negative 4 plus 1/6 of 24, that's negative 4 plus 4, which is also 0. This is not looking great. And then I have 3/2 plus negative 1, which is what? 1/2. Negative 6, 24, negative 6. Now this might look slightly different than the solution that we got on our answer key, but that's okay because regardless we get the same outcome, right? We have basically this row right here is telling us that 0x plus 0y is equal to 1/2. In other words, 0 equals 1/2. This is not true. Not true. This means that we have no solution. No solutions. Basically, these two lines are parallel to each other. Again, if you did this slightly different by maybe you went on ahead and divided row 1 or added 1/3 of row 2 to row 1 in order to cancel out that 0, that's okay. As long as you get this no solutions answer by getting something like 0 equals 1/2 or something like that, you are good to go. So hopefully this helped a little bit. Let me know if you have questions on this video or Gaussian elimination, and I would be happy to answer them. See you later.